A baseball diamond is a square with side 90 feet. A batter hits the ball and runs toward the first base with a speed of 24 feet per second. At what rate is his distance from the second base decreasing when he is halfway to the first base? To formulate the problem, we need to get familiarized with the parts of the baseball diamond. This is the first base, while this is the second, and this is the third. It is obvious that from the starting position to the first base, then to the second and back to the starting position, a right triangle is being formed with legs of 90 feet each. From Pythagorean theorem, the distance from the starting position to the second base is now equivalent to square root of 90 squared plus 90 squared, or equivalent to 90 square root of 2 feet. The path of the player can be denoted as variable y. As the player runs toward the first base, its distance from the second base changes. This position, where the player is at the 45 feet, also forms a triangle, but this time it is not a right triangle, but an oblique one. We can then equate the distance from the second base to the midpoint of the distance from the starting position to the first base as variable x. To formulate an equation that we can derive, we need an angle. Since the vertical line bisects the 90-degree angle of the square baseball diamond, it follows that this angle is equivalent to 45 degrees. From the law of cosines, which can be used in oblique triangles, it states that the opposite side x squared is equivalent to the side 90 square root of 2 quantity squared plus y squared minus 90 square root of 2 multiplied by y multiplied by the cosine of the included angle, which is 45 degrees. With this equation, we can now derive the variables x and y with respect to t, or with respect to time. And this is equivalent to 2x dx over dt equals 2y dy over dt. The derivative of 90 square root of 2 squared is equivalent to 0. And we have negative 180 dy over dt on the third term. Isolating dx over dt will give us 2y minus 180 over 2x multiplied by dy over dt. To get the value of dx over dt, we need the values of x, y, and also dy over dt. From the given, we have y as 45 feet because that is the midpoint of the distance from the starting position to the first base, and the dy over dt is the speed of the batter, which is equivalent to 24 feet per second. With only x as the remaining variable, its value can be solved using the same equation with the cosine law. But we need the values of y to be substituted here so that the only variable remaining is x. And the value of y is, again, 45 feet. With the value of y given, our x is equivalent to 45 square root of 5 feet. Together with the value of y and dy over dt, we can now solve for the value of dx over dt, which then give us negative 10.733126 feet per second. The negative sign indicates that the distance is decreasing as time moves